So it says write them as an algebraic expression. In your book, you have all of these kind of words that tell you what you're talking about. So you should recognize those words and know that they give you either addition, subtraction, multiplication, or division. The other thing that you do need to know, which is why I pulled this particular one, is you need to know like the word cubed or squared. That means you're going to have an exponent. So cubed specifically means written to the third power. Squared would mean written to the second power. And then you also need to recognize your words. Sum, that should make you think of addition. And so you would rewrite this as an addition problem. All right? So you should be able to recognize those and translate those from words to algebraic expressions. The next section says the word evaluate. Evaluate just means plug it in and do order of operations. So whatever it tells you those variables are, plug those in and then do order of operations. So we have y. It said that y is -1. Minus x. It said x is -6. Divided by 5. So we would do our parentheses first. Remember, subtracting a negative is adding the opposite. So that's just adding. So we have -1 plus 6. That's just 5 here. And then we do our division. 5 divided by 5 gives us the answer of 1. So evaluate just means plug it in and do order of operations. Parentheses, exponents, multiplication, division, addition, subtraction. We also did some problem solving where we had to know the formulas. And so it says refer to page 52. I've also put it here. You should be able to recognize which formula you need and plug it in correctly. So they said in this particular problem, perimeter of a rectangle. So that is going to be the distance around a rectangle. So we're going to go to rectangle and we are going to use the perimeter formula. And they give us the length and the width. So we literally just have to plug it in. 2 times the length plus 2 times the width. And again, you're just doing order of operations. 2 times 7 gives you 14. 2 times 3 gives you 6. So your perimeter here is 20 inches. 20 inches. So your next set of questions is simplify. Simplify is just combining like terms. You cannot solve for x because there is no equal sign, all right? So you're not trying to say x equals something. There's no equals to begin with. There will be no equal in your answer. All right, simplify just means combine whatever terms are alike, which also means you don't do any opposites. You're literally just telling me how many of each you have. So you're going to look at this first one and say, well, I have x's. I can only combine my x's. Here I have 1x. Here I have 3 x's. So altogether I have 4 x's. I have numbers without x's. How many numbers? Well, I have +6 here, -9 here. So I have a -3 there. And so once you're at this point, you are done. You cannot simplify that anymore because you do not have any more like terms to simplify. You do notice, though, that they get progressively a little bit more difficult. So if you look at this next one, you have parentheses, which means you're going to have to distribute. So we're going to leave this 4 alone right now, and we're going to distribute this -8. So we have the -8 times the +10v. That's -80v. We have a -8 times a -10. That's a +80. And then at this point, we're just combining like terms. I have a 4 and an 80. That's 84. This -80v, it has a v in it, and there's nothing else that has a v, so I cannot do anything else with it. I am finished. Solve each equation, and this actually goes on to the next page as well. You'll notice it starts out with just basic equation solving. The first one is x plus 12 equals 11. I don't have anything to simplify on each side. Both sides are as simple as they get. I am moving things by addition or subtraction across the equal sign. So here I'm doing the opposite. My goal is to get this x by itself. So I look and I have a plus 12. I need that on the other side, which means here I am going to do the opposite. It is an equation, means it's like a balance. So if I subtract 12 there, I need to subtract 12 on the other side. And then I just bring everything down. I bring down this x because it didn't have anything to combine with. The 12 and the negative 12 cancel out. I need to bring down my equal sign. And then I need to perform this operation 11 minus 12. That gives me a negative 1. Negative 1. And so x equals negative 1 is my answer there. You move from one step to multi-step equations. So this one has multiple things going on. You have an addition going on and you have a division going on. So remember, you're kind of doing, kind of trying to get things by themselves. Remember that if you have a numerator, that thing is grouped. So we need to leave that alone till we get rid of that 6. The 6 is division. It's being divided by 6. So I need to multiply by 6 here. I need to multiply by 6 here. On the left-hand side, 6 over 6 cancels out, which is really what I want it to do. If I'm dividing by a 6 and I multiply by a 6, all that happens is the 6's cancel out, and I'm left with just the r plus 1. On the right-hand side, I have negative 2 times positive 6. That gives me a negative 12. And then now I have a basic one-step equation. I have an r plus 1. I need to move it over. Since it is adding, I need to subtract. If I subtract on the left, I have to subtract on the right. On the left-hand side, that cancels. I'm left with just the r. I need to bring down that equal sign. Negative 12 minus 1 is negative 13. And so that is my answer there. You'll notice that they, as I said, they get progressively more difficult. So you'll see them start to add distribution, and then you'll see them add variables on both sides of the equation. So if you have a distribution, you're going to have to distribute first, which means you leave the 6 alone and you distribute the negative 7. Negative 7 times positive 6b is negative 42b. Negative 7 times positive 5 is negative 35, and that equals negative 155. I do need to simplify both sides before I can move on. Remember, when you're simplifying a side, you do not do the opposite. So I have a positive 6 and a negative 35. I just combine those. The negative 42 cannot combine with anything. If I have a positive 6 and a negative 35, I'm going to subtract and keep the sign of the larger, so that's negative 29 equals negative 155. And now I am going to move things across the equal sign. It's as simple as it gets on both sides. So now I'm going to add this 29 to both sides. All right. It will cancel here. I have negative 42b that's left over here. Bring down my equal sign. Remember, when you have a negative and a positive, you are subtracting. And so negative 155 plus 29, you subtract 155 minus 29, right? And you get what, 126? And it should be negative because this larger one was negative, right? And then my final step here is to divide. Divide both sides by that negative 42. On the left, it will cancel. This divides perfectly. Negative 126 divided by negative 42 is a positive 3. So positive 3 is my answer. You can always check it. Plug it back in and just do order of operations. All right. I also pulled number 40 from the next page. This is also more complicated, but you also have variables on both sides of this equation. So for this one, I need to not only distribute, but I need to simplify and get all my variables to one side and all my numbers to the other. So I can simplify the left-hand side. 4b's and negative 8b's. Those are like terms. Positive 4 and negative 8, just simplify. You're not doing the opposite. You're just combining them. That's a negative 4b. On the right-hand side, I need to do distribution and combining terms. Remember, a negative just means a negative 1. Negative 1 times positive 3b is negative 3b. Negative 1 times positive 1 is negative 1. I also have to distribute the positive 6. 6 times 3b is positive 18b. Positive 6 times negative 3 is negative 18. So while my left-hand side is as simple as it can get, my right-hand side has like terms. Again, you are not doing the opposite if you are just combining the terms on one side. So I have a negative 3b and a positive 18b. That's positive 15b. If I have a negative 1 and a negative 18, that's a negative 19. So now both sides are as simple as they can be. And since they're as simple as they can be, I need all my variables on one side and all my numbers on the other. Since I already have a b over here with no numbers, I'm going to move the b's over to the left. So this is a positive 15. I want to subtract 15 to get rid of it. If I subtract 15b there, I need to subtract 15b on the other side. You're going to add down. Negative 4 and negative 15 is negative 19b. Bring down your equal sign. The positive 15 and the negative 15 canceled. Bring down the negative 19. Don't forget that has a negative in front of it. And then my last step for these will always be to divide. Divide by negative 19 on both sides. On the left-hand side, I just have the b. Bring down your equal. Negative 19 divided by negative 19 is positive 1. So for this one, it says solve by eliminating either your fractions or your decimals, depending on what you have. For decimals and fractions, you can get rid of them. Fractions, you need to look for the least common denominator. So I'm going to look at my 3 and my 21, and I'm going to say, what's my least common denominator? Well, my least common denominator between those two is 21. And so I'm going to take this and I'm going to multiply by 21. And I'm going to take this and I'm going to multiply by 21. When I do that, my denominators will cancel. 3 cancels with 21 and leaves just a 7. 21 cancels with 21 and leaves just a 1. So I have 7 times negative 2. That's negative 14x. And I have 21 times, or 26 rather, times 1 gives me just 26. So now my final step here is just to divide. Negative 14 on both sides. On the left it cancels. I have x equals negative 26/14. The one thing I do need to look for here is, can I reduce? What goes into both 26 and 14? 2. So I can divide top and bottom by 2. So x is going to equal negative 13/7. Negative 13/7. With decimals, you really are just going to look and see how many decimals does the most one have. So I have 1 decimal here, 1 decimal here. The highest number of decimals I have is just 1, so I'm going to move everything over 1 decimal place. You do not have to move anything inside the parentheses. It's already being accounted for right here. So don't go inside the parentheses and move anything, just the stuff on the outside. So I need to move everything over 1 decimal place. I'm going to move this over 1 decimal place. I'm going to move this over 1 decimal place. So this is just 6. So -6. And I don't touch the inside of the parentheses. And over here I get 288. And now I'm just going to solve. I have -6 times -6k is positive 36k. I have -6 times -6 is positive 36. That equals my 288. Both sides are simple, so I'm just going to subtract. Subtract my 36 from both sides. It cancels here. I'm left with 36k equals, just subtract. I get 252. All right. Now, when you started with decimals, you want to actually do long division if you need to. This one actually divides out evenly. You do divide both sides by 36, but my answer was in decimals. So if you get a fraction, you do want to change it into decimals, right? You can reduce this if you want to. What goes into both 252 and 36? Obviously 2 does, right? So anytime you have this, you can reduce until you get to smaller numbers. So 2 divided by 2 is 1, 5 is 2, carry the 1 is 6, right? 126 over 18. Can you reduce more?
Yes.
Yeah, what goes into 126 and 18? 3 or 2, either one, right? Which means if both 3 and 2 go into it, 6 goes into it, by the way. But even if you don't see that, you can do it either way. Yep, so 6 is going to go into both of these. So 6 goes into 12 2 times. It goes into 6 1 time. 6 goes into 18 how many times? 3. What's my answer going to be here? 7 is my answer. So if you have a large fraction, you can reduce it down until it's smaller. And even if it wasn't a whole number, then you would have smaller numbers to do long division with, by the way. Or you could go all the way back and do 252 divided by 36 and do long division. You'll get 7, either way. But for your decimal ones, if it ends up not being a whole number, go ahead and keep going until you have a decimal, because your original problem was in decimals. But if it started out in fractions, your final answer can be in fractions. Daniel has 5 times as many quarters as dimes. If the total value of his coins was $16.20, how many of each kind of coin does he have? All right. So for this one, we really only have 2 different coins. Some of them tell you 3 coins or 4 coins or whatever. All right, so we have quarters and dimes. My quarters, I don't know how many, and my dimes, I don't know how many, all right? But they relate the quarters back to the dimes. So I'm actually going to do my variable for my dimes. I'm going to say that X is dimes. If my X is dimes, how would I write 5 times as many dimes? If my X is my dimes.
5x.
Yeah, it's just going to be 5X. So this is the number of coins for my quarters and my dimes. Well, what's the value of each of those? Well, the value of a quarter is 25 cents. The value of a dime is 10 cents. So how do I figure out how much I have of each? Well, I just multiply. 0.25 times my 5x will be the quarters, and 0.10 times my dimes will be the dimes. All right. Total value is $16.20. I have to add my quarters to my dimes to get my total value. So if I have 0.25 quarters, that's the quarter value, times the number of quarters, and I add it to my dime value, 10 cents times the number of dimes, that should equal my total value of everything that I have, right? And then I'm going to use my shortcut to get rid of those decimals. I will always, always, always move these two decimal places for dollars and cents because dollars and cents are always in two decimal places, right? And so I can move this over two places, I can move this over two places, and I can move this over two places. So I have 25 times 5x, I have 10 times x, and I have 1,620. Just multiply. 25 times 5x is what? 125x plus 10x equals 1620. We need to combine our like terms. 125 and 10 gives us 135x. And then my final step here is to divide. Now, just like we did on that last problem, 1620 and 135, there's a very easy number that you can tell goes into both of those, right? It's a 5. If it ends in 0 or 5, it's divisible by 5. So you can really reduce this by 5 before you start doing long division. 5 goes into 16 3 times with 1 left over. 5 goes into 12 2 times with 2 left over. And 5 goes into 20 4 times, right? So you can divide those by 5. 5 goes into 13 2 times with 3 left over, and 5 goes into 35 7 times, right? And so what goes into 324 and 27?
Just 27.
Yeah, 27 does actually, but you can reduce it. Yeah, 3 and actually 9 goes into both of them, by the way, right? So 324 over 27, you can do long division. You're going to get a whole number there, by the way. Or if you want to make your number smaller, you can certainly divide by something that you see goes into it. 3 goes into 3 1 time. 3 goes into 2 0 times. 3 goes into 24 8 times. 3 goes into 27 9 times. By the way, this is divisible, right? And it's easy to see. 9 goes into 10 1 time with 1 left over. 2 times. You're going to get 12. If you had done long division right here at this point, you would have gotten 12, by the way. But you can reduce your numbers so they're not so big. What did I solve for if I solved for 12? I solved for x, which represents what? Dimes, right? So if I know that I have 12 dimes, how do I figure out how many quarters I have?
You add 5.
Multiply by 5. So I have 60 quarters.